So last thing for today, horizontal asymptotes. This whole day has really been about horizontal asymptotes, when I'm approaching far to the left and when I'm approaching far to the right. My definition of a horizontal asymptote is as follows. If the limit as x approaches infinity of my function, f of x, equals some number L, or if the limit as x approaches negative infinity of f of x equals some number L, then we can say f has a horizontal asymptote at y equals L. If the limit as x approaches infinity of my function is L, or the limit as x approaches negative infinity of my function is L, then I can say that f has a horizontal asymptote at y equals L. All of this means at most I could have, what do you think? At most, how many horizontal asymptotes could a function have? At most, you could have 2 horizontal asymptotes. One to the left, one to the right. Nothing in the middle matters. Let's look at a few of these. I should have also given you that worksheet, 3.5, horizontal asymptotes. I want to try to find my horizontal asymptotes and then do some matching with the graphs on the bottom. Number 1, to find the horizontal asymptotes, well, I'm going to set up 2 limits. The limit as x approaches infinity of my function f of x, and I'm also going to do the limit as x approaches negative infinity of f of x. Because this is just a rational function, top and bottom are polynomials, I'm going to look at the limit of the ratio of the leading terms. This is the limit as x approaches infinity of 4x squared over 2x cubed. The other one is going to be the limit as x approaches negative infinity of 4x squared over 2x cubed. Figure out both of those limits and submit your answer to Edpuzzle. This is the limit as x approaches infinity of 2 over x. This is the limit as x approaches negative infinity of 2 over x. Both of those should end up being 0. Do you have a graph that's getting close to y equals 0 on both sides? What letter on the bottom do you think? I think that looks like letter C. Getting close to 0 on the left, getting close to 0 on the right. 1 is going to be C. Try the same thing in number 2. Find the limit from the left, the limit from the right. Oh, hold on, sorry. I also wanted to add in the equation of my asymptote. The equation of my asymptote, y equals 0. Go do that in number 2. Find your 2 limits, figure out the equation of the asymptote or asymptotes, and then tell me what letter it is. Plug a huge number in there, you get 2. Same thing's going to happen from the other direction. I do promise at some point they're going to start being different values. Limit as x approaches negative infinity of 4x to the 4th over 2x to the 4th is the limit as x approaches negative infinity of 2. That is also going to be 2. So we have one horizontal asymptote here. It's y equals 2. And looking at your graphs, Looks like there's a horizontal asymptote at y equals 2 on the right, but that's not the case on the left here. I think B is going to be the one that's approaching 2 from the right side and also 2 from the left side. Number 2 is B. Number 3, we're going to go set up our two limits. Actually, I think you can take a moment and deal with this one. This goes back to our variations about how we deal with square roots. Try number 3. That top one, the thing inside the bars is positive, so I can just drop my bars and say this is the limit as x approaches infinity of 2x over x. Just going to give me 2, some room for number 4. The one down here is the limit as x approaches negative infinity of 2x over negative x. That is negative 2. I should approach 2 from one side, negative 2 from the other side. I think that's going to be D. I'm getting close to 2 from the right, negative 2 from the left. D is my answer, and my asymptotes are y equals 2 and y equals negative 2. And also, I know that it's approaching 2 on the right side because that was my limit as I approached regular infinity, and negative 2 on the left because that was the limit as I approached negative infinity. I know that you know what letter 4 has to be, but let's go through the calculations for number 4. If I'm doing the limit as x approaches infinity of that function, well, from our exponential variations, 2 to a huge number is way bigger than 2. 3 to a huge number is way bigger than 1. So I can just look at the limit as x approaches infinity of 2 to the x over 3 to the x. Please finish that limit. This equals the limit as x approaches infinity of 2/3 to the x. 2/3 to a huge number, that thing is less than 1, so something less than 1 to a huge number is going to be 0. One of my equations is y equals 0. The other one is the limit as x approaches negative infinity of f of x. What do you get there? Well, 2 to a negative huge number, that's really small. That's really close to 0. Minus 2 over 0 plus 1. Negative 2 over 1, you're getting negative 2. Y equals negative 2. Yep, that agrees with letter A. I'm approaching 0 on the right, negative 2 on the left. Again, like everything else in this unit, make sure you're being careful when it comes to your notation, your limit symbols, and all of that. And that does it for limits.